So in this class we will be solving the few more problems on Carnot cycle. So here the question is, a Carnot cycle operates between the temperature limits 280 degrees Celsius and 27 degrees Celsius. The overall volume expansion ratio is 16. So determine the first you need to find out is the volume ratio of the isothermal and adiabatic processes, and the second bit is the thermal efficiency of the cycle. When assume, if it is given as assume, that is nu is equals to 1.4. So as the name it's here it is mentioned here, that is Carnot cycle. First what shall we do is we shall draw PV and TS diagram for Carnot cycle, PV, and this for TS diagram. So you know very well the Carnot cycle is a combining of 4 processes, that is 2 adiabatic and 2 isothermal processes. First is the adiabatic process, adiabatic compression process. 1 to 2 is adiabatic compression process, right? Next 2 to 3 is a 2 to 3 is a isothermal process. 3 to 4 is a 3 to 4 is again adiabatic expansion process. 4 to 1 is a isothermal process. Now you can draw here then TS diagram, that is it will be like this. You know very well this one, 1 2 3 4. This is adiabatic process, entropy is equals to constant. This is isothermal process, temperature is equals to constant. So first you need to write down the given data, that is what are the given data here. So first he has a given, that is nu is equal to 1.4, as well as the temperature values are given. So what are these temperature values? That is lower temperature limit is T1, or T1 you can also take it as a T4. T4 is equals to 27 plus 273. This will be equals to and the 10 and this will be and then 300 Kelvin. Similarly T2, that is T2 is equals to T3. You can see here T2 and T3 both are same. This 280 plus 273. This will be equals to 553 Kelvin. 553 Kelvin. Now, so first we shall find out that is a volume ratio of isothermal as well as adiabatic processes. Okay, so what is this volume ratio means? That is V1 by V2, V2 by V3. You have all seen like that. While solving while deriving the equations for thermal efficiency and work done, we have came across a term, that is compression ratio, or we can call it as a volume ratio, that is V1 by V2 is equals to RV. Like this, we need to find out the RV, that is compression ratio or volume ratio. You can call it as a volume ratio. So you know very well there is a combination for adiabatic process, that is T2 by T1. This is very well known thing for you people. V1 by V2. This is gamma minus 1 divided by gamma. Whereas T2 is equals to T3 and T1 is equals to T4. We can take T3 by T4. That is will be equals to T3 by, if T3 by T4 is will be equals to V4 by V3 to the power gamma minus 1 divided by gamma. Sorry, we can take gamma. Sorry, it is not a gamma minus 1 divided by gamma, only gamma minus 1. Okay. Now we can take T3 by T4 is equals to V1 by V2 to the power gamma minus 1. Whereas we can take if you take we are supposed to find out this ratio. So we know the value of T3 and we know the value of T4. You can take only this much only and you can solve, or you can take this much or solve. Okay. Whereas this V1 by V2 you need to find out. This is a RV, compression ratio. So when we are supposed to find out V1 by V2, what we have to take? V1 by V2 take one side, and you need to take this power term on this side. When I take power on this other side, means what happens? This T3 by T4 will be power, in the power it will be 1 divided by gamma minus 1. So whereas this V1 by V2 is nothing but the compression ratio RV, that is T3 is equals to 553 divided by T4 is equals to T1 is equals to 300 Kelvin to the power 1 divided by gamma is 1.4 minus 1. So the compression after calculation you are calculating, you will be getting the RV as 4.613. This is the compression ratio. This is unitless. So next we shall find out the B bit, that is thermal efficiency. Thermal efficiency, you know the formula of thermal efficiency, that is T2 minus T1 divided by T2. You can write like this also, T1 divided by T2. Okay, whereas this we can so now we know the value of T1 is that is we have already these are already given data, 300 by 553 Kelvin. So your thermal efficiency will be 45.8%. So one more thing we have missed here, that is what is that one means. In the part A, he asked to find out the volume ratio of the isothermal and adiabatic process. Now we have found out the volume ratio of adiabatic process. We need to find out that is isothermal process as well. So consider isothermal processes, that is 2 to 3 and 4 to 1. So the volume ratio is equals to, so that is volume ratio is equals to V4 by V1, that is V4 by V1, that is V4 by V1 we can take like this, V4 by V1. I will be multiplying this one with multiplying and dividing by V2 and V2 divided by V1. Whereas this V4 by V1, so if you read the question carefully, here he is mentioned overall volume expansion ratio. Overall volume expansion ratio means that is from here to here. You can see overall volume expansion ratios from V1 to V4, that is how much this is a value is given, that is V4 by V2, that is 16, and whereas V1 we got the answer of V1 by V2 as 4.2613, but here we are having for V2 by V1, so I can take this value in the denominator. So this will be V4 by V1 is equals to you will be getting 3.468. This is a compression ratio of adiabatic process. This is a compression ratio of isothermal process.